All right, 4.2, graphing linear equations. Let's see here. Yeah. All right. Obviously, you said you hadn't needed to really have graph paper. And as I stated, you need to have some graph paper for the next week or two here as we get through these sections in in chapter 4. But all right. All right, what we're going to talk about is, first of all, they're going to give us several types of equations, okay? They're going to give us equations in function form. For example, y is equal to 3x minus 5. Okay, they're going to give us equations in function form. They're going to give us equations that are in regular form, which is like 2y minus 4x equal 8. Okay? They're also going to give us equations in regular form like this, and they're going to want them in function form. Okay? They're going to want us to take this and put it in function form. This is our regular equations that we're used to seeing. Okay, this is in function form. Okay, and in this, they're going to want you to graph the equations also. Okay, so the first thing I want to look at is how do we take an equation and test solutions. Okay, that's the first thing we're going to look at, is taking equations and testing the solutions to that equation. For example, if I have 2y minus 4x equal 8, okay, and they tell me that they want to know if this ordered pair of -2 and 8 is a solution. Well, we got to remember back to what we talked about the other day. There's the x, that's the y. It's very important that you understand the order because you have to plug those values into the specific equation. Okay? You have to plug those values into our equation. And to do that, we have to know which one is x. This is x, so it's going to go where that x is. And this is y, and it's going to go where that y is. And so your equation, once we've substituted in these values, is going to look like this. 2 times 8 minus 4 times -2 equals 8. And what we have to do is we have to finish it out. Okay, we have to take and multiply 2 times 8. Well, 2 times 8 is 16. Minus 4 times -2 is -8 equal 8. Well, now I have to take and go plus. And 16 plus 8 is 24. 24 is 24 equal to 8? Well, obviously not. Okay, and so this is no, it is not that ordered pair is not a solution to this equation. Okay, and so that's the first thing they're going to get you to do. It doesn't really get any harder than that. Okay, it's just a matter of knowing and making sure that you plug in the right value for the right variable. Okay, let's look at another example of those. Well, better yet, let's do this problem. -2x, -2x minus 9y is equal to 7. and the solution that they're going to give you is they think that the solution is negative 1 and negative 1. So I want you to do that right quick. I want you to plug in those values, and I want you to tell me when you have the answer, raise your hand. We're going to see if that is a solution to our problem. Now, as you're doing it, the reason why we have two solutions is because we have two different variables. In the equations we're used to solving, you only had x, or you only had y, or you only had t or v. You only had one variable in the equation. Well, now that we have two variables, we've got to have two solutions, okay? And so that's why you've got an ordered pair that's your solution now instead of just one number. All right, Brianna, is it a solution? Yes? No? Yes? Okay. We have several people that say no, several people that say yes. Okay, well, let's look at it. Let's make sure. We have negative 2 times negative 1 minus 9 times negative 1 equals 7. Now, in this particular case, you really don't have to know which one's x, which one's y, because they're both the same. So you're just plugging in a negative 1 for each variable. Well, that gives us a positive 3 minus positive 2. Excuse me, I was adding there for a second. Positive 2 minus negative 9. Okay? Well, once again, plus, plus. So that's 2 plus positive 9, which is 11, equals 7. Okay, so it would be a no. Okay? Now, if you didn't change if you said that was a negative, and then, you could look at it maybe being right, or if you messed up on our two negatives here, obviously here, that's a negative and that's a negative, so that's why it's a positive. Okay? So, that's the first thing we're doing. Okay? The next thing we are doing, number 2 is to find ordered pairs for an equation. Okay, now, all right, to do this one, there's basically 3 steps, okay? Actually, there's 2 steps. We're getting to the third step in a second. There's 2 steps. First of all, you need to rewrite the equation in function form. Okay. Step B is to choose a few values for x and make a table of values. Okay? We're going to look at these 2 steps right now. Okay? The third step that we will look at in just a second, the third step is to plot the points from our table of values okay, and then draw a line through the points. Okay, what we're going to concentrate on right now is A and B. Okay, that's what we're going to concentrate on right now in this particular one. All right, so let's look at this problem. Y equal 3x minus 5. Now, this is the part that, for some reason, students tend to get confused on. Okay, I'm not really sure why, but they just do. You're coming up with the values for x. Okay, so if you're coming up with the values of x, Larry might say, hey, I'm going to use 0, 1, and 2. Okay. Zach may say, well, I want to use 3, 6, and 9. Okay. Both of those are acceptable. Okay. And so it really gets hard because now all of you could have different answers. Okay, obviously, if Larry decides to use 1, 2, and 3 for x and plug them into this and come up with his table of values, and then Zach uses 3, 6, and 9, then obviously Zach's table is going to be different than Larry's table. Okay, so I think I'm going to look real quick here, see if in the book if they use the same ones every time. Yes, they do. Okay, so for our purposes, I'm going to go ahead and give you the ones to use. This is for problems 21 through 29. Okay, this is for problems 21 through 29. They don't give you these in the directions, these values. I am going to give them to you right now. We will use -1, 0, and 1. Okay? -1, 0, and 1. Those are the values that you're going to use. The reason we're going to use those values is because that is what the answers that we'll call out tomorrow, okay, will be. All right? So that's what they'll be connected to. So everybody use -1, 0, and 1. But understand, it would not be wrong if, except I told you to use these values, it wouldn't be wrong if you wanted to use 2, 4, and 6, or, 10, 12, 14, or you could use -3, -2, -1. Okay, so eventually we will get to a point where everybody may be using different values, but your line will look very similar. Okay, it won't necessarily go through the exact same points, but it'll be very similar. Okay, now, so we're going to plug in these values into that equation. Well, that equation's already solved in function form. Remember, function form is y equal something. Okay, usually x, maybe 3x, maybe half x, maybe, there's just so many different things it could be. But this is already in function form. Okay, that is function form. So I'm going to plug in the values that we've talked about. So I'm going to say y is equal to 3 times -1 minus 5. Okay? And when you get that, you get y is equal to -3 minus 5. Okay? Once again, this is plus a negative. And so that gives me y is equal to -8. So what they mean by table of values, and I'm going to see if they do it horizontally. Yeah, okay. What they mean is you have x and you have y, and we said our x value is -1, then our y value is -8. Okay? Now, the next one we're going to use is y equal 3 times 0 minus 5. So when x is equal to 0, y is going to be equal to what? What? -5. So, when x is equal to 0, y is equal to -5. Then our last value, if x is equal to 1, so I'm going to plug that in, y is equal to 3 times 1 minus 5. And so what would y equal? -2. And so when x is equal to 1, y is equal to -2. Does everybody understand why it's -2? 3 times 1 is 3. 3 minus 5 would be -2. Nick? Yes, that is one problem. Yes. Because it's impossible to graph a line if I only have one point. And now, you can graph it, a lot of times you can graph it with 2 points, but that third point you get in there to make sure you haven't made a mistake on one of the other 2 points. Okay? And so, yeah, that's one problem. And like I said, it's math. It's not going to get easier. So, that is our solution. Now, all we're dealing with right now is the ordered pair, step 1 and 2. So the ordered pair here, to list this out, would be -1, -8 in parentheses. Then you would have 0, -5 in parentheses. And then you would have 1, -2 in parentheses. And that would be your 3 answers. Okay? So you can understand why I want everybody to use the same ones. Because, A, I don't want to have to take up your papers and go through 9 problems myself and figure out whether you used the correct numbers or not, or whether you came up with the correct ordered pair. Okay? That would take quite a bit of time, and so we're going to, like I said, for our purposes, we're going to use those values right there. Now, I want you to also use those values for problems 36 through 51. Now, that doesn't mean we're doing all of those problems, but any of the problems I assign from 21 through 29 and 36 through 51, I want you to use -1, 0, and 1. And we'll look at some of those. We may revisit that in a little bit, but well, we're getting there. Just let me deal with this section. We're dealing with the first 2 steps first. We'll deal with graphing the equation here in a second. All right, let's look at this one. Y is equal to 1/2 parentheses 4 minus 2x. Okay? Once again, we're going to use our table of values. So I'm going to do an x and a y. We're going to use -1, 0, and 1. Okay? Obviously, it's not a complete table. All right? It doesn't have the top and bottom numbers. I mean, the top and bottom bars and everything, but that's good enough. Okay? Y'all are all about, is there any way I can make this shorter? We just made it shorter. You don't have to draw the bottom, top, You don't have to fill in this right there, okay? All right, so let you not draw 4 lines. All right, now, plugging in those values, that's what we do. We plug it in. So y is equal to 1/2 times 4 minus 2 times -1. I was going to make a bracket, but I'll make it a parentheses. All right, so that gives me y is equal to 1/2 times 4 minus -2. So that's plus. So that's y equal 1/2 times 6. Y is equal to what? 3. 1/2 times or half of 6. 1/2 times 6 means half of 6. Half of 6 is 3. All right, so that's the first one. Next one. Next one's fairly simple because you have y equal 1/2 times 4 minus 2 times 0. Okay, 2 times 0 is what? 0. 4 minus 0 is 4. Okay? Yeah, whatever. So that gives you 1/2 of 4, which is 2. So y is equal to 2. So when x is equal to 0, y is equal to 2. Now, when x is equal to 1, so y is equal to 1/2 times 4 minus 2 times 1. Yeah.
How you got 2 is, how did you do it? Because it's 4 minus 2, would you change?
No. 4 minus 2 times 0. I have to do this part first, which is 4 minus 0. And that's how I got this 4 right here. Was 4 minus 0. All right, now, down here, this gives me y is equal to 1/2 times 4 minus 2. Because 2 times 1 is 2. And y is equal to 4 minus 2. 4 minus 2 is 2. So y is equal to 1/2 times 2, which is 1. Now, I go back up here and plug in 1. Okay, and you can see the pattern. Okay, there's a pattern to all of this, just like when we talked about functions in 7th grade. This is just a function table. Okay, we talked about function tables last year in 7th grade. It's an input-output table is another thing we call them. Okay, we had input-output tables. That's all this is. Okay, it's just this is a function, this is a function table, or an input-output table. But there's a pattern. Okay, here's my pattern here. I'm just going by 1 each time. Well, in this particular problem, go from 3 to 2, it was 1. To go from 2 to 1, it's 1. Okay, so there is a pattern a lot of times. These things you may not be able to pick it out with just two inputs. Okay, now, Larry, what is your question, sir? How can I help you today, sir?
Okay.
Why didn't you order lunch today?
Because chicken fried steak.
Do you usually order chicken fried steak?
Not really.
You do sometimes, right? You and Avery do sometimes, not all the time. Depends if they have that cherry cobbler, right? You know, hey, do you notice they had mandarin oranges twice this week? Man.
Okay.
All right. All right, what's your question?
So, y equals 1/2. Okay. I did a different way. I changed since 1/2 times 4 is 2.
You distributed the 1/2.
Yeah.
Yes, you could do that first. Yes. What Larry's question was, and it's a good question, even though we had that sidebar with chicken fried steak knowledge, here's what Larry did. Larry went ahead and before he started plugging in the values, he went ahead and distributed the 1/2 to the problem, which you can do. If you take that, you have 1/2 times 4 minus 1/2 times 2x. Okay, and when you do that, that gives you y is equal to 2 minus 1x. Okay, that's acceptable. You can do that. Okay, you can do that. That's not a problem. Now, the problem you do run into sometimes is, what if that would have been a third? Okay, if it would have been a third, 1/3, then obviously you don't have that neat little 1/2 of 4, 1/2 of 2. You would have 1/3 of 4, 1/3 of 2. At that point, you wouldn't want to do it. You wouldn't want to distribute it. You'd want to get the value in the parentheses and hope that, and that's the problem. That's the problem that we're going to talk about here in a second, is a lot of times that -1, 0, and 1 doesn't work well. Okay? And so we'll talk about using different values at that point. Now, so that's step 1 and 2. Well, the only difference, let's go ahead and get our answer up here. Our answer to this is, the answer is not the input-output table. Okay? The answer is the -1 and 3 as my first ordered pair, the 0 and 2 as my second ordered pair, make it more like a 0 instead of a 6, and then the 1 and 1 as my third ordered pair. That is the actual answer to these problems on 21 through 29. Okay? So don't just leave the input-output table. That's not your answer. The actual answer is these ordered pairs. Okay? Well, step 3 is to take these ordered pair. I'm going to move them down here so I can do what I need to do. Let's see. The first one was -1 and 3. Okay? There really probably needs to be a comma between those so you don't think you're multiplying them. I don't know how you would think you would multiply -1, 3 with something else. But, hey, stranger things have happened. All right? All right, so there's your ordered pair. Now, let me change my paper here. There we go. Change it to our graph paper. Now, so step 1 and 2, or step A and B, we've accomplished with this. Now we're going to take and graph these points. Okay? We're going to graph these points. Now, -1 and 3. Here's -1, and we go up 3. 1, 2, 3. So there is -1 and 3. Okay, now we're going to do 0 and 2. Well, 0 and 2, here's 0, so I go over 1, 2. Okay, so that is 0 and 2. And then the last point is 1 and 1. Do what? Well, hang on here. Hang on. I am doing something to tell you why we get three values. Okay? Now, if you were doing this, your line is sort of out of whack. Okay? It would work. Okay? But realistically, your line is supposed to be, because Caleb and them were mentioning, 0 and 2 is really supposed to be right here. Okay? Now, it would eventually... Whoa, I didn't want to do that. Hang on here. My bad. Switch it back. I'll just see if I can get it without getting the... Yeah, I'm going to go to my actual eraser here so I can do it with my point. Maybe I can do it without erasing that there. That's not going to let me erase that. There it goes. Good. There we go. There. Oh! There you go. There you go. All right, now, your point should have been, okay, your point should have been this right here, okay? Now, eventually, yes, actually, in all actuality, okay, that is where this point would have been, because you can tell that it's going through there, through here, and then the next one would have been here, right, that right there, okay? So if I would have done a fourth point, that would have been it. This would have been 2, okay? X value would have been 2. The Y value would have been 0, okay, if we did the next point. So there's your line right there, okay? That's your line. That's how you would have graphed it with those points that we were given. Let me go here with my line. Okay, that would have been your line, and so that would have been all 3 steps. Take an equation, rewrite it as a function, come up with a table of values, and then graphing it. Okay, that's the 3 steps, or plotting the points as they call it. That's the 3 steps that we would have taken. Okay, so step 2, this was step 2, come up with the actual values. Step 1 is this right here. This is step 1. Okay? Step 2, this is part of step 2, the actual values there in the table. And then step 3 is actually plotting the points. Okay? Bella?
What's the answer?
Well, it depends. Okay, it depends which one they're asking for. You're going to have problems that actually ask for all 3 steps. One will say, rewrite the equation in function form. That would be step 1 up here. If they ask you to, let me write them out for you. That way you'll know. Okay, if they ask for function form, they want you to take the equation and rewrite it in function form. Well, that's step 1 of our process. If they want you to, next way they say it, is they want you to come up with a table of values, okay? That's the step 2 that we just did. If they ask you to graph the equation, okay, that is step 3 that we just did. So those are the 3 things that they're going to ask you for. Is they're going to ask you to rewrite the equation in function form. That's step 1. Okay, there's not realistically, there's one section of those. We'll look at those in just 1 second. Actually, we won't, because I don't think we're having enough time. Larry? What?
No.
May you get a tissue? Yes, you may. Let's see. We get out of here 10:54, right? Yeah, we still got a little bit of time. All right. Cole, what's your question? Mr. Owen Cole. I always call you Cole for some reason. I know it's Owen. I always do that. You don't have to write what? No, on table of values and graphing the equation, you have to do a table of values to get to those answers. on step 1, where they just ask you to rewrite it in function form, then that on those you do not have to write a table of values, obviously. Okay? Now, let's look at the last part, the part where they want you to take and write an equation in function form. We've done this, okay, y equal 12. All right, we did this in Chapter 3. Okay, we did this in Chapter 3 where they told you to solve the equation with the relationship of y to x. That's what this is. Okay, so this is rewriting the equation in function form. Okay, so my answer in function form, like we just talked about a few minutes ago, my answer is going to look like y equal blank. Y is going to equal, x plus 12 or 3x plus 12 or, something to that extent. So, this one is fairly simplistic to solve. Negative 3x plus y equal 12. They want me to get y by itself. So to get y by itself, I have to take the negative 3x over to the side with the 12 on it. Okay? Now, this is where there's two basic ways you can do it. Easiest way is just over here it was a negative, so over here it becomes a positive. Okay? And so that's positive negative 3x. Okay.
Per day, and each day you'll get one of these.
All right.
So after you record the individuals today, you just chunk that, and tomorrow you'll get
okay.
one.
All right. Sounds good. Thank you. All right. So over here it was a negative 3x. We take it to the other side of the equation, and it becomes a positive 3x. And so over here it becomes a positive 3x. Now, here's the part you need to get used to. Okay? If you look at it like that, you're tempted to do this. Okay? That's not wrong, but you just need to get in the habit of putting the number or the coefficient and the variable x first in it. So it really needs to look like this. That's what it needs to look like. And that is your answer to that problem, where they say rewrite the equation in function form. Like I said, y equal 12 plus 3x is not wrong, okay, but we're going to do things with this right here, this form, in the next 3 sections. And so it might confuse you if you don't rewrite it or write it like this, okay? Because we're starting to get into in the next few seconds, we're going to talk about slope. We're going to talk about slope-intercept form. We're going to talk about y and x intercepts. And in all those things, they want you to write the function form like this, okay, and not like y equal 12 plus 3x, okay? So get in the habit of putting this, when we move it over, picture it right there in front of the 12 instead of behind the 12. Okay? Yes, Caleb.
So if it's a positive?
So if it would have been, yes, if it would have been positive, if this would have been 3x plus y equal 12, when you move it over here, now it becomes negative 3x. And that's all you got to do. Yeah, so that's why I say this is the easiest way. The inverse operation, okay, the inverse operation would say, okay, I'm adding negative 3x, so what do you got to do? Subtract negative 3x. You take and subtract negative 3x over here, and what does 12 minus negative 3x mean? 12 plus 3x, okay? And so it's the same thing. This is just a lot less complicated, okay? It's the same thing as what we've learned. This is just the way that me and Miss Markham, our old math teacher in high school, used to teach it, was we always had this rhyme, change the side, change the sign. And that's how we used to teach it. I don't believe Miss Brewerton teaches it that way, and I don't think Miss Shorter teaches it that way in Algebra 2. But it's the same thing. So when they say, well, I'm adding here, just subtract negative 3x, that's the same thing, okay? It is exactly the same. It's just a different way to put it. And I've always found at this age you understand, and, well, bottom line is kids these days want the shortest method possible, usually, okay? And so that is the answer for that one, okay? Now, we're running short on time, so here's what we're going to do. I'm going to split this lesson up, the homework-wise, into two days, okay? Because there's a lot of stuff you had to learn today. So we're going to do the first part of it today. The first part of it today is, let me see here. We're going to do 15 through 29, okay? We got 4.2, 15 through 29 all. Okay? And then we'll work at the other part of it tomorrow. All right? You may go.